Welcome students, I am Muhammad Naveed and you are watching my YouTube channel. In this lecture we are going to find the area of the region that is enclosed by the cardioid r is equal to 2 plus 2 cos of theta. Student, remember, whenever you deal with a polar curve, first try to sketch the polar curve. So here first we try to sketch this curve. Our given curve is a horizontal cardioid. This is a rough sketch of our polar curve. We have to find this area. Our curve is r is equal to 2 plus 2 cos of theta. Here theta is equal to 0, theta equal to pi by 2, theta equal to pi, and theta is equal to 3 pi by 2. The formula we used to find the area bounded by polar curve is area equal to integration from alpha to beta 1 by 2 r square d theta. In this case, our curve is symmetric about x-axis. So first we try to find the area which is above x-axis, and then we find the whole area by reflecting this curve about x-axis. So for the region above x-axis, our theta varies from theta equal to 0 to theta equal to pi. So in this case, our area is equal to 2 times, as this curve is symmetric about x-axis. So first we find area above x-axis, and below this curve r is equal to 2 plus 2 cos of theta. Remember, here this is our point r equal to 4, and this point is r is equal to 2. So in this case, our theta varies from 0 to pi 1 by 2. R is equal to 2 plus 2 cos of theta. So r square means 2 plus 2 cos of theta whole square d theta. Here 2 is cancelled out and we are left with integration 0 to pi 2 plus 2 cos of theta whole square d theta. Now we have to evaluate this definite integral. This is equal to integration 0 to pi. First we open this square. 2 square equal to 4, 2 cos theta square equal to 4 cos square theta plus 8 cos of theta whole d theta. In next step we can write it as integration 0 to pi 4 d theta plus integration 0 to pi 4 cos square theta d theta plus integration 0 to pi 8 cos of theta d theta. This is equal to, we take this constant outside this integral 4 time integration 0 to pi d theta plus 4 time integration 0 to pi cos square theta d theta plus 8 time integration 0 to pi cos of theta d theta. This is equal to 4 time integration 0 to pi d theta plus 4 time integration 0 to pi, as cos square theta is equal to 1 plus cos of 2 theta upon 2 d theta plus 8 time integration 0 to pi cos of theta d theta. This can be written as 4 time integration 0 to pi d theta plus, here 2 and 4 is cancel out, 2 times integration 0 to pi d theta plus integration 0 to pi cos of 2 theta d theta plus 8 time integration 0 to pi cos of theta d theta. Four time integration d theta is equal to theta, and theta varies from 0 to pi, plus 2 times again integration d theta is equal to theta, and theta varies from 0 to pi, plus integration cos of 2 theta is equal to sin 2 theta upon 2, and theta varies from 0 to pi, plus 8 time integration cos of theta is equal to sin theta, and variation of theta is 0 to pi. This is equal to 4 time integration, now theta varies from 0 to pi, we can write it as pi minus 0 plus 2 time, again we write it as pi minus 0 plus sin 2 pi upon 2 minus sin 0 degree is 0, so this becomes 0 plus 8 time sin pi minus sin 0. Now this becomes 4 pi plus 2 pi, as sin 2 pi is 0 and sin pi is also equal to 0, and sin 0 degree is again 0, so our final result is 6 pi. So our area is equal to area bounded by cardioid is equal to 6 pi. If you like this video, don't forget to subscribe my YouTube channel. Thank you very much.